What's up, Cambridge? I don't know if we're going back to school, when we're going back to school. I'm not snowed in. I don't know if y'all are snowed in, but I feel like math is probably the most important thing that you're going to do throughout your high school career. So I feel a little obligated as your math teacher to put up some math for you over your snow day. So I want to start. I picked a skill that's really easy to do on a webcam. It is in our unit, but it's not the first thing that we're going to go over when we get back. It's just something easy for me to do that will get you thinking about math before we go back to school. If you want to follow along, it is page 323. It is lesson 6.1, and it's basic exponent rules. This should be review, but if it's not, please, please, please memorize the chart on page 323. You're going to be making flashcards next week on this chart, so it is in your best interest to go ahead and learn it now. So we're going to be talking about what you do when you have a variable and an exponent and you want to add, subtract, multiply, or divide. You guys should have all seen this on the pre-test you took for me if you've taken my pre-test. So this will actually go over some of the answers to that pre-test. Okay, so we're going to go over 4 properties of exponents in this video. And the first one is, what do you do when you multiply a variable with an exponent? Like, what do you do? All right, so let's say you have the variable x and it's squared, so it's x to the second power. All right, that 2 is your exponent, and you want to multiply, keyword people, multiply. We are multiplying x squared by x to the third power, okay? So write down on your paper x squared times x to the third power. The way you solve that, the correct answer to that is you put the equal sign, keep the variable the same. So everybody on your paper, write x. All right, what you have to do with the exponents though is add them. All right, so I know we're multiplying and you end up adding the exponents, but that is a rule that you need to memorize. So the answer here is x squared times, that's your multiplication sign, x to the third power is actually equal to x, keep your variable, 2 plus 3, which is 5. Okay, you do not multiply the exponents when you have this type of situation here. All right, another example would be x to the fourth power times x to the third power. That's going to equal x to the seventh power. All you do, stick the equal sign there, keep your variable, add the exponents. All right, that's rule number 1. It's the first rule in that chart on page 323 of your book. All right, the next one I want to go over is anything, variable or number, it doesn't matter, anything to the first power is always going to be itself. So x to the first power is the same thing as x. 7 to the first power equals 7. P to the first power equals p. 10 to the first power equals 10. All right, anything to the first power is always just what's underneath the exponent. All right, so I wrote an example. Oh, by the way, everything that I wrote the first time ended up being backwards, so I had to rewrite it all backwards so that when I showed it in front of the camera, it would like come up the right way. All right, so x to the, x to the first power, right here, equals x. And again, any number to the first power, these are just the earlier notes up here, any number to the first power, like 2 to the first power, that's going to equal 2. It doesn't matter the letter, it doesn't matter the number. If it's raised to the first power that's got a 1 exponent, it's equal to itself. Every single time, people, this doesn't change. So on your end of course exam, on the ACT, wherever you see anything to the first power, remember, pull back from your knowledge from Ms. Bryan's class that anything raised to the first power is always itself. All right, so that's the second rule. Third rule we're going to talk about is anything to the 0 power. So check out this right here, x to the 0 power. It's always 1. I don't care if it's p to the 0 power, 1. 7 to the 0 power, 1. 3 to the 0 power, 1. Any number or letter, if it's raised to the 0 power right here, let me get that in there, zoom in on that. If it's raised to the 0 power, it's always going to be equal to 1 every single time. All right, so again, on the end of course exam, on the ACT, wherever you see a number or a letter raised to the 0 power, no matter what it is, it always equals 1. All right, both of these are on your chart on page 323. Please, please, please memorize them because this is an easy mistake. You know, it's easy to say anything to the 0 power is always itself. And that's not true, right? As you see here, and as you'll see in your notes, anything to the first power is always itself. And anything to the 0 power is always, always 1. All right, I'm praying this is making sense. All right, the fourth rule we're going to go over has to do with division. So instead of saying something like x squared times x cubed, we're now going to do x to any power divided by x to another power. So it looks like this. All right, x to the 5th power divided by, because this is a division sign right here, people, we should know this. This right here, a fraction bar, is the same thing as division. X to the 5th power divided by x to the 3rd power. All you're going to do, again, keep the variable the same. Keep the number the same. Whatever is your base, whatever's this thing right here, keep it the same. And subtract the two exponents. So as you can see here, 5 minus 3 is 2. This is a simplified final answer to this problem right here. X to the 5th divided by x cubed is the same thing as x squared. All right? X to the 7th power divided by x to the 4th power would be x to the 3rd power because 7 minus 4 is 3. All you do, again, keep the same variable and then subtract your exponents. All right, so those are the 4 rules. Review them on your chart on page 323. Let me know what you thought of this video, if it made sense or if it confused you more, if you want me to put up more or if you think that this is crazy. And hopefully I will see you soon, and if not, study your chart on page 323.